Everyone, welcome back. First of all, I would like to tell you something. See, if you are opening the videos in your mobile, then for your kind information, uh, YouTube has changed the setting, and you can't run your video in mobile uh, with a 720 pixel or 1080 pixel. Means HD content is not available over mobile due to coronavirus. Okay, so if you want to see HD videos of these, means whichever teacher is sending you any video, no, then if you want to see them in HD in clarity with 720 or 1080p, then you can see those videos uh, with your desktop or laptop. Okay, with mobile, this problem you might be facing. Okay, so so today we are starting with this chapter, polynomials. And one more thing, if you are not able to understand anything, no, the message should directly come to me via comments below. Okay, you should comment and you should tell me, sir, this is the problem, or please help me out. Okay, this way I'll be able to help you. Fine, direct communication should be there. Okay, for now we are starting with polynomials. We'll start with some of the definitions today. See, polynomials, you have heard the word in 8th also, in 7th also, but you don't know actually the meaning of the polynomial. So we'll discuss each and everything, whatever you have studied till now for algebraic expressions. See, some definition that you also need to write. Okay, first, constant, a symbol having fixed numerical value. What? Numerical means number. Okay, numerical means number. So a symbol having fixed numerical value is called constant. So here it is 4, a fixed numerical value. It is a numerical value. We can't change 4. 4 is just 4. We can't say it is 3. Okay, minus 4, 4 by 7, root 2, 0, pi. Pi value is something 3.14 and so on. Okay, and this is irrational number. This we have discussed. So these all are having fixed numerical value. So these we call constant. Okay, so the second is variable. A symbol which may be assigned different numerical values is called variable. See, we'll write a symbol and it is representing a different values. X, we can't say what is x. X can be 1, x can be 0, x can be minus 1, x can be root 2, x can be root 3 by 2, x can be anything. So it is variable. Variable means which keeps on changing, which is not fixed, which is not constant. So variable, you should know the meaning of the word variable. Variable means to change. Okay, which is not fixed. It is just the opposite of fixed or constant. It is just the opposite of constant. It is variable. Constant means we have a fixed value. Variable, we do not have any fixed value. Value will keep on changing, or it can take different values, so it may vary. Okay, so you should understand this. After this, algebraic expression. With the help of constant and variable, we can study algebraic expression. Combination of variables. If you will combine variables and constants. Okay, and how to combine them? Connected by operators, either plus, minus, multiply and divide sign. With the help of these operators, we can make algebraic expressions. Okay, what kind of algebraic expression we are talking about? For example, this is a variable and this is a number, and this number means constant, and this is variable. X can take any value, so it is variable. So combination of variable and constant, and it is combined by which sign? Plus sign. So this is what? Algebraic expression. Okay, 2x. Here 2 and x are in multiplication, that's why we have written 2x. So these two are, this is a constant value and this is a variable, and they are connected by a multiplication sign. So now it is 2x. Fine. Or like this also, this is also an algebraic expression. After this, terms of algebraic expression. See, these are different parts of, if we are talking about any algebraic expression, just take this 2x square plus 3x plus 1. Now there are different parts of algebraic expression which is separated by either plus or minus sign, which is separated by either plus or minus sign. See this. This is one term because after this we have a plus sign. This is another term because before this we have a plus sign, and after this also we have minus sign. And this is the last term. Have you understood? Means these are different terms of algebraic expressions which are connected by a plus or minus sign. Okay. One more thing. If I am talking about the third term here, this is the first term, this is second term, this second term is plus 3x, and this third term will take with minus sign, this is minus 1. Okay, I hope you have understood. What I want to say is consider the sign when we are talking about terms, because this 2x square we don't have any sign, it is plus 2x square, and this is plus 3x, and this is minus 1. So we have three terms here, plus 2x square, then plus 3x, and the third one is minus 1. I hope you've understood this terms of algebraic expressions. After this, polynomial in one variable. Now, first of all, we'll study polynomial in one variable. What is this? Now, we have studied algebraic expression. Okay, we have studied algebraic expression. Now, any algebraic expression in which one variable, any algebraic expression in which one variable is only used. Any expression in which one variable is used and in which power of the variable is a whole number. Means one variable we are using, either we are using, if we are using y, then it will be with y square plus y minus 2, or 2y square plus y minus 2. Okay, so suppose we are taking this algebraic expression where we have used only one variable, that is y. We have not used x, or we have not used z in this, or a or b or c, whatever. Okay, so any algebraic expression in one variable in which the powers of this variable, see there are two variables here, y, and here one more time y, fine, and both the variables are same, and the powers on this should be whole number. Here the power is 1, and here the power is 2, and 1 and 2 are, what are 1 and 2? 1 and 2 are whole numbers, and whole number starts from 0, 0, 1, 2, 3, and till infinite. Please try to understand the concept. The concept of polynomial is very, very and very important, because on the basis of this chapter, your rest of the chapters in 9th and 10th depends. Okay, you will learn a lot many things here in this chapter, and many of the concepts will get clear, and this is new, totally new for you. Fine. So look here, this is a polynomial in one variable. See, what are the condition? Any algebraic expression, so we have took any algebraic expression with one variable, we have took one variable x we are using, in which power of the variable, what is the power of this variable? 2. And what is the power here? It can be cited as 1, it can be called as 1, because we do not have any power, it means it is 1. So 2 and 1 are whole number. This way we have to check. If the power of the variable is a whole number, it means it is a polynomial in one variable. After this, here we have 2 power, here we have 1, it is also a polynomial in. See, in this C point, here we have power 19. So see this, all powers 2, 1, 3, 1, 19, all powers are whole number. If powers are whole number, then obviously it is a polynomial. Simple, very simple definition we have written here. Otherwise, if you will see R.S. Agarwal, then you will not be able to understand the meaning of the definition, okay, which they have written. Okay, it is a typical form, but here it is very simplified form of the definition of the meaning of polynomial in one variable. Okay, now note one thing, always express polynomials in descending powers. See, 2, 1, then we don't have any power, then 2, 1, I have not written this 3x first, I have written 2x square first, because from highest to lowest power will move, and make this your habit. We can move from lowest to highest power also, but we will move from highest power to lowest power. Okay, so in descending order of the powers, we will write our polynomial. Okay, this can be referred as standard form of polynomial. So whenever we are writing a polynomial in this way, then that is the standard form. Okay, this is the standard form of any polynomial. So classification of polynomial on the basis of degrees. Classification of polynomial on the basis of degrees. What is degree? Means the highest power in the polynomial. Fine. So linear polynomial. What is linear polynomial? In which we have degree 1. That is linear polynomial. For example, this. Here see, we have one variable, that is x, and here we have the power 1. So degree is 1. That's why this is known as linear polynomial. Quadratic polynomial in which the degree is 2. Okay, for example, this ax square plus bx plus c, here the highest power is 2, so that's why degree is 2. Cubic polynomial, polynomial with degree 3 is called cubic polynomial. Standard form is, these are the standard form from highest power to the lowest power. Okay, and here the highest power should be in cubic 3. Fine. Biquadratic, or we can say it quartic. Okay, biquadratic polynomial or quartic. Biquadratic means double of quadratic, can be. Okay, see here what can be, it is polynomial with degree 4, with degree 4, so double of this. Here we have degree 2, here we have degree 4, so this is the standard form. So classification of polynomial on the basis of number of terms, this you have done in lower grades, monomial, binomial, trinomial. In this we have only one term, in this we have two terms, and in this we have three terms. Listen it very carefully. You have to write all these definitions in your uh, notebook. Fine, fair notebook. Starting from this constant, and write all the definition, whichever whatever I have written here. You have to write it down same as it is in your fair notebook. It will help you in clearing the concepts. Now, constant polynomial. Polynomial containing one term. See, these no students are not aware. Even if you will ask a 10th grader, they'll get confused in these definition. You should be aware of this. Constant polynomial, a polynomial containing one term only, and that one term should be a non-zero constant. What is non-zero constant? Any number which is not zero, any number which is not zero we can't write here because it is non-zero constant. So constant, we know any number, okay, which is having a fixed numerical value. So these are all the fixed numerical values, but it should be non-zero, simple. So zero we can't include, rest all the numbers we can write here. So constant polynomial is a polynomial in which there is one term, and that one term is also without variable, and that too should be non-zero constant. For example, 2. What, 2 is a polynomial? Maybe you are having doubt on this. Sir, how 2 is a polynomial? We don't have any x here, we don't have any y here, we do not have variable. And you said, sir, a polynomial is a combination of, or algebraic expression is a combination of variable and constant. And polynomial is also algebraic expression, so it should also be a combination of variable and constant. It is fine, it should be a combination of variable and constant. Now look here, if suppose I said no, the power can be whole number. Look here, if a power is 0 and 0 is a whole number, and this is true, and you know that here the value of x raised to power 0 will be 1, because anything raised to power 0 is 1. So what is this? Equals to 2 only. So 2 can be a polynomial, because here something is existing, here something is there, any polynomial is there with power 0. That's why we are saying that 2, 3, 23, minus 65, whatever I have written here, all are polynomials, and these all are constant polynomials, we say this. Okay, and here degree of the polynomial is, what is the degree here? Degree of the polynomial is 0, because we do not have any variable here. It means the power of that variable might be 0. That's why it is not existing here. Fine. After this, 0 polynomial, that polynomial in which we are only including 0. So 0, what is this? A 0 polynomial. A polynomial consisting of only one term. There is only one term, namely 0, and it is called a 0 polynomial. And this degree of the polynomial is not defined, and we don't know what is the degree of the polynomial here. So whenever they are asking for degree of 0, then it is not defined. We can't say regarding the degree of the 0 polynomial. Okay, it's not defined. Now these are all the definition and the concepts on which our chapter will be. Okay, we are going to discuss on these terms, and whatever we are going to study now will be based on these terms. Okay, now we are starting with exercise. Okay, so now we are starting with exercise 2.1. Which of the following expression are polynomials in one variable? So we have studied the definition 2. Now let us discuss regarding which of the following are the polynomials in one variable and which are not. We have to give the reason to also for our answer. Okay, we'll keep on right at the side the reasons for this. Okay, and you can write in your notebook. Question number 1. as I have told you the definition, that polynomials are those in which we have the variable with power as whole number. Okay, power of the variable should be whole number. First first 4x square minus 3x plus 7. How to write this? We'll write, yes, it is a polynomial in one variable. See, for one variable there is no need to give reason, because it is visible that we have only one variable here, that is x. Okay, and we can write here in bracket, that is x. Okay, still if you want to write, you can write here in bracket x. So it is a polynomial in one variable as power of, same reason we'll write, as power of variable, as powers of variable, okay, as whole number. As a power of the variable here is whole number. See this 1, see this 2. So these two are whole number. Powers of the variable are, you can write here, grammatical error. Powers of variable are whole number. So I hope this is understood. Very simple reason we have to give. The reason again and again we have to write this only. Okay, so no further more reasons we have to justify this solution. Again, y square plus root 2. Here this is again, yes, it is a polynomial. Yes, it is a polynomial. Okay, in one variable, you can write it full polynomial in one variable, and that is y, as power of the given variable is the variable is whole number. So I hope you can write this. So one more, jump on to the third part, 3 root t. Now look here very carefully, t root 2. See carefully, if any number is in root, then no problem at all. Okay, if any variable is in root, then it is not a polynomial. How? The concept is same, reason will be same. Look here, if this variable t is in root, is in root, look here, you need to focus here. How we can write this root? We can write this root as 1 upon 2 power, and you should be aware of this. Maybe I have told you in chapter number 1 that root, square root is equals to power 1 by 2. If this is this, so it can be written as this. If this is cube root, then it is power 1 upon 3, and if it is fourth root, then it is power a raised to power 1 by 4. So what is this? We can write it as 3, then t power 1 by 2 plus t root 2. So how we will write? This is not, it is not a polynomial, as why to write one variable? Because it is not a polynomial. Simple. Okay, it is, there is only one variable, but it is not a polynomial. So it is not a polynomial, as power of the variable, power of the variable is not a whole number. Have you understood? 1 by 2 is not a whole number. Whole number starts from 0 and it should be a complete number. Find whole number, a complete number, whole, complete. Okay, till infinite. Numbers like this, not in fraction. Fine. That is in fraction, it is not a polynomial. Fine. After this, fourth part. What can you say about fourth part? You'll say, sir, here we have power 1, here we have power 1, so it is a polynomial. But no, it is not a polynomial. Look here one more time. You need to see all the factors. y plus 2 upon y. How we can write it as y plus 2, this y is in denominator, so if we'll write it in numerator, then it is actually the power minus 1. So that's why it is not a, so same reason you can write it is not a polynomial, because the power of the variable is not a whole number, it is negative. So we can't write variable in denominator. If it is written, you need to shift it in numerator to check the original power. Okay, after this we have the fifth part. In fifth part we'll write, see, the power all are whole numbers. So it is a polynomial. Yes, of course, it is a polynomial, but not in one variable. We have used three variables here. So what we'll write in fifth? In fifth, we'll write it is a polynomial, but not in one variable. Here, three variables are used. Have you understood? It is a polynomial, but not in one variable. So I hope this is clear. The first question. After this, find the coefficient of x square. What are the coefficient? This also you have studied in 6th, 7th, 8th. Now you are in ninth. Coefficient of x square means the number present with x square, means it should be in multiplication with x, means it should be in multiplication form, means there should not be any plus or minus sign in between the number and this uh, x square. We do have any number with x square? No, we, this is some plus sign and 2 is another term, so please do not write this 2 as the coefficient. So here we do not have any number, so we'll write here 1. So in question number 2, so we'll write like this. You also should write in the same manner. Coefficient of x square is 1. As we do not have any number with x square, no, in the question, that's why we have to write here 1, and it is plus sign, so it is plus 1. Fine. After this, here we do not have any number with x square. Okay, look here carefully. If this is x square, no, if it is written minus 2x square, then this minus 2 is coefficient. I've told you, no, they should be there should be an operation of multiplication. 2x square means 2 into x square. Fine. Okay, or division will also work. If it is like this, see in this, in the, what is the coefficient of x square? Pi is in multiplication, 2 is in division, so this pi upon 2 is the coefficient of x square. So it should be with x square. Okay, without any plus or minus sign in between. So here we do not have any x square, so let us wait. Now you give me the answer once, then this question you can write by your own. Okay, the answers of the question you can write by your own. I have told you how to write. Coefficient of x square is this. In the second also, coefficient of x square is, what is the coefficient of x square here? Minus 1. And third, coefficient of x square is pi upon 2. And here coefficient of x square we do not have, so coefficient of x square is 0. Because we do not have x square, so coefficient is also 0. Now question number 3. Give one example of binomial of degree 35. Binomial, I have told you. What are binomial? Binomial with polynomial with two terms. Okay, these are binomials. So binomial with degree 35 degree. Okay, y plus 1. But here what is the degree? 1. So we can make it degree 35. Clear? So this is the binomial because it has two terms, 1 and y raised to power 35, and it has degree also 35. Fine. And one more thing is asked in the same question, monomial with degree 100. Monomial means one term only with degree 100. Okay, any you can write, it is your choice, but only one term they have asked with degree 100. So we can write x raised to power 100 or y raised to power 100, z raised to power 100, any. Okay, monomial also we have done. Now what is the degree? Degree means the highest power in the question. Okay, so here the highest is 3, so we'll write here the degree in this equation is 3. In this equation I am saying, in this polynomial is this, and degree here is 2, and degree here is, what is the power of t? 1, and degree here is, we do not have any variable, so it is 0. Okay, now after this, now you should know, maybe some of you are not aware of the degree properly. Let me tell you something regarding degree. Question number 6 is all about degree. 6 I am saying. What was this? This is question number 3. This is question number 4. Okay, let's talk about degree. Can you tell me degree in this? X square uh, y cube plus y4 plus 1. X square y cube plus y4 plus 1. You know here degree. This is not means what can I say about this? You can tell me the degree here. Degree here might be you're thinking that the highest is 4. No, this is not. The highest is if they are in multiplication, then we have to add up, and the degree here is 5. Is that clear? Because these two variables are together, and if these two variables are together, then we have to add up the powers. Means this is not a rule of law of exponent. This is not any rule of law of exponent, but to find out the degree, we need to do this. Okay, and so 5 is highest here, so we'll write 5. If there is a sign of plus here or minus here, then the degree is 4. But if we do not have any sign here, it means they are in multiplication. Fine. If they are in multiplication, then we have to add up the power to find out the real degree. Fine. One more example, this I have given you. Okay, so can you tell me in this now? X square y square plus y4 plus x square z cube. What is the highest? Here we have, yeah, some of you are correct. It is 5, 4, and here also 4, and here we have 5. So degree is 5. I hope you have understood. Rest, if you will open RS, then you'll get to know many more things, lot of things. Okay. So after this, classify the following as linear, quadratic, or cubic. For linear, I have told you one thing, degree should be 1. For quadratic, I have told you one thing, degree should be 2. For cubic, I have told you one thing, degree should be 3. So here the degree is, highest power is 2, so it is quadratic. 3, so cubic. 2, then quadratic. This is 1, then linear. This is cubic, quadratic, linear. I have written the answer here, but you need to write it in your fair notebook. Fair notebook you have to use to write these answers. Okay, so write all the answers in fair notebook and write it properly. Don't write only q here or l here. Write just x square plus x. Then in solution just write quadratic polynomial in this way. Okay, so this question number 5. Question number 5. First, x square plus x, the solution being quadratic polynomial. Okay, so we have discussed basics today, and we are not going to start the second exercise today. First of all, you need to understand all the definitions, and on the basis of all the definitions only we have discussed this exercise. On the basis of all the definitions only we have discussed this exercise 2.1. That's why we have done today this exercise also together with the definitions. Okay, I hope you have understood. If any problem you are having, then in any problem, okay, related to this, any kind of problem, you should comment below. Fine. And you can share the videos with your friends, those who are not studying, fine, so that they should study. Okay, bye, take care.